Section 4.5a is about identifying linear equations. A linear equation is an equation that when you graph it, it forms a line. Now, all linear equations can be written in what's called the standard form. And I'm going to show you what the standard form looks like. ax plus by equals c is the standard form of a linear equation. That means you can rewrite any equation that's a linear equation in this form. Now let's talk about it a little bit. A linear equation has an x value and a y value. These letters A, B, and C all represent numbers, and there's some specific things about these numbers you have to know. A, B, and C, they're integers, which means they cannot be fractions or decimals, and they have to have a GCF, or a greatest common factor, of 1, which means they can't have any other factor that goes into them. This is what the standard form of a linear equation looks like. If you can write any equation in this form and get it to look this way, you know for a fact that the equation is linear. And we're going to spend time looking at a lot of equations and trying to identify if they're linear equations or if they're not. And if they are, they can be rewritten in this form. Here we're asked to determine whether this equation is linear, and if it is, we have to write it in standard form. Well, just looking at it, I see an x and a y, which is a good sign. It has two variables. They're not being multiplied, which is also a good sign. So I think this probably is going to be linear. To prove it to myself, I have to make sure that I can write it in standard form. Now down here, I'm going to rewrite what standard form looks like, because this is what we're working towards. We want the x and the y value to be on the same side, and then a number to be on the other side of the equal sign. So how can we accomplish that? We already have the y on the left, but the x here is on the right side. So I'm going to take this minus 2x and I'm going to add 2x. I'm going to do it to both sides to keep the scales balanced. And now I'm going to rewrite this. Y plus 2x equals 5, and then negative 2x plus 2x is 0, which is actually a good thing because I got my x and my y on the same side, so it's closer to standard form. But it's not quite there yet. The reason why is because I should have my x value written first, and the commutative property says I can do that. I can just rewrite this as 2x plus y equals 5. Now, this is written in standard form. The 2 is my a, the y has a 1 in front of it, so the 1 is my capital B, and the 5 is my c. So this can be written in standard form. This is what it would look like, and then we can now say that this is, yes, a linear equation. Here's another equation. We're asked if it's linear and to write it in standard form. Well, I see an x and a y, which is a good thing, but there's a problem. See this x times a y? You can't multiply variables. If you want a linear equation, you can't multiply variables, because a linear equation looks like this, or at least has a standard form that looks like this. You can't multiply the x and the y. So there's really no way that I can separate this x from this y. If you see any variables being multiplied, or being divided for that matter, you can immediately say that it's not a linear equation. Here's our next equation. Is this linear? Well, if I remind myself what standard form looks like, this looks pretty good. It's got ax plus by equals c form, so this seems like it should be linear. But if you remember the definition of standard form, let's go back to that. We said that they have to have a GCF of 1, which means they can't have any other factors other than 1 between them. And if you look at this, a 3, a 9, and a 15 all share a common factor of a 3. So what I'm going to do is I'm going to divide everything by that 3, that common factor. And I'm going to do 3 divided by 3, which is 1x, 9 divided by 3, which is 3y, and 15 divided by 3, which is 5. So this is now written in standard form. It looks like this, and we can say, yes, this is a linear equation. It's just not written in standard form from the start. This example, it has the potential to confuse a lot of people, and the reason is it doesn't have an x. If you notice that, it doesn't have an x, and our standard form is ax plus by equals c, and so you may be tempted to say it's not linear because it doesn't have an x. But I want to point a couple things out. First of all, see this 1/3? I would prefer that we didn't have fractions, because your standard form cannot have any fractions in them. So I'd like to first get rid of the fraction here. Instead of a 1/3, I'd like it to become a 1, so I'm going to multiply it by a 3. And what I do to one side, I also have to do to the other side. And now these 3's will cancel. 3 cancels with 3, leaving myself with a 1y equals -3. Now, that's a little better because I don't want to have fractions when doing standard form. But I still don't have the x that I was talking about. But I want to show you something. What if I wrote it this way? What if I wrote it with a 0x plus 1y equals -3? Well, it's easy to see that your c is -3, your b is 1. Well, what's your a? Your a is 0. It turns out that this is standard form. It's just written with a 0 for my a. So this is the standard form of this line, and therefore this line is linear. This is a special one. Whenever you have a y equals a number, it's a linear equation. Even though it's missing an x, it's linear. Now, more specifically, it is going to be a horizontal line here at -3. This is what the line y equals -3 looks like. Whenever you have a letter that equals a number, it's a linear equation. It's just written a special way because the other letter has to have a coefficient of x to write it in standard form. This one, looking at this, is it linear or is it not? Well, right off the bat, you notice an x, y, and a z, and you can't have 3 variables. You can only have 2. If you have 3 variables of any kind, you can look at it and just say it's not linear. There's no way you're going to be able to write it in standard form, and you're done. In this equation, we have an x and a y, which lends me to think that this should be a linear equation. The only thing that's wrong with it right now is there's a y on the right that I'd like to move to the left side. So I'm going to move that over here and make it 3/4 x minus y equals 8. I'm going to write down the standard again to remind you this is what we're working towards. So it looks pretty good actually right now. I got my x, I got my y. It doesn't have to be a plus sign. You could have a minus because all minus signs could be written as plus a negative anyway. So this looks pretty good. The one thing though that I cannot have in standard form is a fraction. So I'm going to have to find a way to eliminate that fraction. Some of you might be thinking reciprocal, and that would get rid of this fraction, but it would create more fractions over here, so I don't want to do that. So what I'm going to do is I'm going to multiply by the denominator. I'm going to multiply that by 4. That means you got to multiply everything by 4. And watch what happens. 4 cancels with 4, leaving a 3x. 4 times y is 4y, and 8 times 4 is 32. So now you can see my a is a 3, my b is a -4, and my c is a 32. That is standard form. Therefore, this is indeed a linear equation. Our next equation is here. We're looking to write it in standard form. It looks pretty good, but hopefully you'll notice that they all share a common factor of a 3. So I'm going to divide everything by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And 27 divided by 3 is 9. This then is our standard form, and therefore my equation is linear. Is this equation linear? Well, can we write it in standard form? Initially you look at it and you think no because it's missing the y. You also might look at it and say it's got a fraction, so that's a problem too. I'm going to deal with the fraction first by multiplying both sides by 4. So now we'll cancel the 4's, leaving a 1x equals -28. Okay, so that's better, but I'm still missing the y. If you remember back a couple slides ago, we had a y equals, and we said that that is a linear equation. Well, just like that one, this is also a linear equation because the standard form can be written this way. I put a 0 in front of a y, and 0y is really nothing, so I can add that because it's really nothing there at all. But when you add it to x, you just get x. So this is a linear equation. It's a special kind of linear equation. It's a line that is a vertical line at -28. I'm just going to, it looks like this. This is the line x equals -28. But it is linear, and this is what the standard form looks like.